It was a Wednesday morning in Madrid, May 1981. Families were sitting down to breakfast, pouring oil into pans, feeding children before school. Nobody suspected anything. The oil looked normal. It smelled normal. It came in unlabeled containers sold by street vendors and market stalls, cheap enough that working families across Spain bought it without hesitation. Within weeks, hospitals were overwhelmed. People were struggling to breathe. Their lungs were filling with fluid. Doctors had never seen anything like it. Food is the one thing every human being on Earth has in common. We trust it, almost without thinking. We hand it to our children. We consume it in the most ordinary moments of our lives. And in the worst cases, that trust has been exploited, neglected, or simply broken by systems that failed to protect the people depending on them. These aren't stories of natural disasters or unforeseeable plagues. They are stories of contaminated supply chains, ignored warnings, deliberate fraud, and regulatory failures that turned everyday meals into mass casualty events. The consequences fell hardest on the most vulnerable: infants, the elderly, pregnant women, and ordinary families who had no reason to suspect the food in front of them was dangerous. Here are the 5 deadliest food accidents ever recorded. Spring 1981. Spain. Thousands of people across the country began showing up at hospitals with the same strange cluster of symptoms: fever, severe headaches, skin rashes, and most alarming of all, lungs that couldn't seem to work properly. The illness looked at first like an atypical pneumonia, possibly bacterial. Doctors treated patients accordingly. Many got worse. By June, it was clear something else was happening. The disease was clustering in specific neighborhoods and households. Entire families would fall ill while their neighbors stayed healthy. That pattern pointed away from an airborne infection and toward something shared inside the home. Investigators began working backward through the lives of those affected. What were they eating? What were they buying? The answer, when it emerged, was cooking oil. Specifically, cheap cooking oil sold door to door and at informal markets across central and northern Spain. It had no proper labeling, no official packaging, and no regulatory oversight of how it reached consumers. The oil in question was rapeseed oil, also known as colza oil, that had originally been imported into Spain for industrial use. Under Spanish law at the time, rapeseed oil could only be imported for industrial purposes, and to prevent it from being diverted into the food supply, it was required to be denatured with aniline, an industrial chemical compound. The aniline was supposed to make it unfit for consumption. What happened next was a catastrophic act of fraud. The oil was purchased by a refining operation, illegally processed to strip out the aniline, and then blended with other edible oils. The refining was not clean. Residual chemical compounds remained in the oil, including a class of substances that researchers later identified as aniline derivatives, formed when the aniline reacted with the fats in the oil during processing. Those compounds entered the bodies of everyone who cooked with the oil. What followed was a disease unlike anything European medicine had documented before. The illness moved through 3 distinct phases. The acute phase hit the lungs first and hardest, causing pulmonary edema and respiratory failure in the most severe cases. Those who survived the first weeks often moved into an intermediate phase marked by muscle pain, nerve damage, and hardening of the skin. The chronic phase left survivors with long-term disabilities, including fibrosis of the tissues and ongoing neurological complications that persisted for years. Investigators eventually traced the contaminated oil to a refining facility in Seville, identified as Industria Trianera de Hidrogenación. A 1992 World Health Organization review confirmed the causal link between the illegally refined rapeseed oil and the mass poisoning, though the precise chemical mechanism responsible for the illness was never fully established. Attempts to reproduce the disease in laboratory animals using the suspected compounds consistently failed, leaving a gap in the scientific understanding that has never been closed. The human toll was staggering. More than 20,000 people were affected across Spain. Within the first few months of the outbreak, over 330 people were gone. The total death count over subsequent years climbed above 800. as chronic complications claimed lives that had initially survived the acute phase. Thousands more were left permanently disabled. The legal proceedings that followed were among the longest and most complex in Spanish history. Criminal trials ran for years. The lead defendants included the owners and operators of the refining operation, and convictions were eventually handed down, though appeals and procedural complications stretched the process across more than a decade. The disaster forced a complete overhaul of Spain's food safety regulations and import controls, creating new requirements for labeling, testing, and documentation that had simply not existed before 1981. It remains the largest food poisoning disaster in modern European history by death toll and scale. What made it especially sobering was how routine the purchase had seemed. Oil bought for a few coins from a vendor at a market stall, with no label, no warning, and no indication that it had already been rendered lethal by the decisions of a refining operation working entirely outside the law. The families who brought it home had done nothing wrong. They had simply bought what was available and cooked their meals. Summer 1985, California. Pregnant women began arriving at hospitals in Los Angeles County with fevers, miscarriages, and stillbirths. Newborns were dying within days of delivery. Adults were developing meningitis. The illness was listeriosis, caused by the bacterium Listeria monocytogenes, a pathogen with an unusual and dangerous property. It can survive and multiply at refrigerator temperatures. That makes it particularly threatening in ready-to-eat foods that receive no further cooking before reaching the table. Listeria had been known to science for decades, but large-scale outbreaks tied to commercially distributed food were still relatively rare in 1985. What investigators uncovered in California that summer would change how the food industry and public health authorities understood the risk going forward. The source was traced to Mexican-style soft cheeses, specifically queso fresco and cotija cheese, produced by Jalisco Products, Inc., a dairy operation based in Artesia, California. The cheeses moved through grocery stores and markets that served predominantly Latino communities, where the products were used in traditional cooking. They crossed state lines, reaching consumers well beyond California before anyone understood something was wrong. The contamination came down to a failure in the most basic step of dairy production. Listeria monocytogenes is destroyed by heat. Properly pasteurized milk, handled correctly through the rest of the process, should not carry the bacterium in quantities large enough to cause illness. Investigators found evidence that unpasteurized or improperly pasteurized milk had entered the production process at Jalisco Products. The soft, high-moisture character of the cheeses then gave the bacterium an environment where it could not only survive, but grow. Listeria does not strike everyone equally. It concentrates its damage on people whose immune systems are compromised or still developing. Pregnant women fall into that category, and their unborn children are even more exposed. The bacterium can cross the placental barrier, reaching the fetus directly. In many cases, that meant miscarriage or stillbirth. In others, a baby arrived already infected. Born into a fight, the smallest patients had almost no chance of winning. More than 140 people were confirmed infected across the affected states. When fetal deaths and neonatal deaths were counted alongside adult fatalities, the death toll reached into the dozens, placing this among the deadliest listeria outbreaks the United States had recorded up to that point. What the 1985 outbreak made undeniable was the reach a single production failure could have once a contaminated product entered a multi-state distribution network. The cheese left one facility in Artesia and traveled far enough that the public health response required coordination across multiple states. By the time the source was identified, the damage was already done across a wide geography. A family in one state had no way of knowing their cheese, and a family's cheese in another state had come from the same compromised batch. Jalisco Products ceased operation in the aftermath. The case became a reference point in American food safety discussions for years, cited whenever regulators and producers debated the standards around soft cheese production, pasteurization requirements, and the particular danger posed to pregnant women by certain ready-to-eat products. It pushed federal authorities to tighten oversight of pasteurization practices inside cheese facilities and made the case for routine environmental testing on production floors, where listeria can persist on surfaces and equipment even between batches. The victims in this outbreak had not taken any unusual risk. They had bought cheese from a store. The danger was already inside the product before it ever reached them. September 2008, China. The government announced publicly that infant formula produced by the Sanlu Group had been found to contain melamine, an industrial chemical used in the manufacture of plastics. The announcement made headlines around the world. What it did not immediately make clear was how long the problem had been known before anyone said a word. Melamine is rich in nitrogen. The protein tests routinely used across the dairy industry measure nitrogen content as a proxy for protein levels, because nitrogen and protein are chemically linked under normal circumstances. By dissolving melamine into watered-down milk, suppliers could make a diluted, low-quality product appear to pass quality checks. The practice was not limited to one bad actor. By the time investigators had worked through the full supply chain, contaminated products had been identified from 22 different dairy companies operating across China. The internal timeline at Sanlu tells the more troubling story. According to a subsequent State Council investigation, the company had been receiving complaints from parents about kidney stones in their infants as far back as December 2007. Testing eventually confirmed the presence of melamine in August 2008. Rather than issuing an immediate public recall, company leadership delayed. A local government official reportedly instructed Sanlu's board to hold off on public disclosure until the Beijing Olympics had concluded, framing a mass poisoning as a matter of managing optics around a national event. The Beijing Olympics ended on August 24, 2008. The scandal became public on September 13, 2008. For the weeks in between, and for the months before that when complaints had already been accumulating, infants across China kept drinking the formula. Melamine builds up in the urinary tract. In adults, the body can clear it. In infants, whose kidneys are still small and whose systems have no capacity to process an industrial chemical, the accumulation produces stones that can block the ducts carrying urine out of the body. When those ducts are blocked, the kidneys fail. The infants who suffered this outcome had no way to describe what was happening inside them. Many of the earliest cases had already passed before any official count began. By January 2009, China's Ministry of Health reported that 300,000 children had been identified as affected. 54,000 had been hospitalized. 6 infant deaths were officially confirmed as directly caused by the contaminated formula, though health observers and families noted that deaths occurring before the scandal became public were largely excluded from official tallies, and the true number of fatalities was likely higher. The legal response was severe by any measure. 2 men involved in producing and distributing the melamine-laced protein powder used to adulterate raw milk were executed in November 2009. The former chairwoman of Sanlu Group received a life sentence. Other executives and local officials were handed lengthy prison terms. The director of China's Administration of Quality Supervision, Inspection, and Quarantine was forced to resign. The World Health Organization, which was not officially notified until September 11, 2008, described the incident as one of the largest food safety events it had encountered. Its assessment was direct. The scale of contamination across 22 companies made clear this was not an isolated manufacturing failure. It was a deliberate and widespread practice of adulteration running through an entire industry sector that had been allowed to persist by a combination of commercial pressure, regulatory absence, and deliberate suppression of information by the people who had the power to stop it. Beyond China's borders, the contaminated formula had also been exported. Products were identified in markets across Southeast Asia and parts of Africa, prompting recalls in multiple countries. Infants who had never lived in China had been fed the same compromised formula from the same adulterated supply chain with the same exposure to an industrial chemical their kidneys could not process. The youngest victims were measured in months. None of them had been given a choice about what they drank. Late 2008, Georgia, United States. People were falling ill in state after state, and investigators could not find the thread connecting them. The cases were spread too widely, the products involved too varied. Weeks passed before the pattern became visible, and by then the contamination had already moved through nearly the entire country. The source was peanut paste and peanut butter produced by the Peanut Corporation of America, manufactured at processing plants in Blakely, Georgia, and Plainview, Texas. Most consumers never bought this product directly. It traveled into the food supply as an ingredient inside other goods, crackers, cookies, nutrition bars, and institutional food distributed to nursing homes, hospitals, and school cafeterias. That hidden role was what made the outbreak so difficult to trace and so difficult to contain. The strain was Salmonella typhimurium. In healthy adults, it brings fever, severe cramping, and days of illness that most people can eventually recover from at home. For the elderly, for young children, and for anyone whose immune system was already weakened, it could kill. By the time investigators had mapped the full scope of the outbreak, 714 people across 46 states had been confirmed infected. 9 were gone. The product recall that followed became one of the largest in American food history, eventually covering nearly 4,000 separate products across hundreds of brands, all traceable back to ingredients from the same 2 plants. What separated this case from an ordinary contamination failure was the paper trail investigators found inside the company. Stuart Parnell, the owner of the Peanut Corporation of America, had received laboratory results showing positive salmonella findings from within his own facilities. His response was not to stop production. It was to push for the products to be retested, seeking negative results that would allow shipments to continue moving. In some instances, goods left the facility before any test results had come back at all. Internal emails recovered during the federal investigation showed Parnell describing the contamination in terms of lost revenue and shipping delays, treating positive salmonella tests as a business inconvenience rather than a signal that people were about to be poisoned. Physical conditions inside the Blakely plant were documented by federal inspectors. A leaking roof that allowed water to intrude, mold on the walls, roaches on the equipment. None of it had been enough to shut the operation down before the outbreak. One of the people who ate the contaminated product was Shirley Almer. She consumed a peanut butter snack just before Christmas in 2008, while she was already recovering from cancer treatment. Her body had no reserves left to fight a salmonella infection on top of everything else. She was gone within weeks. In September 2015, a federal judge sentenced Stuart Parnell to 28 years in prison, the most severe punishment handed to a food producer in an American foodborne illness case up to that point. His brother Michael, a food broker who had helped move contaminated shipments through the supply chain, received 19 years. The plant's quality control manager was convicted of obstruction of justice. The case drew a line that American food law had not drawn as clearly before. Knowingly shipping a product contaminated with a pathogen, with documented awareness of that contamination, was not negligence. It was a crime. The legal standard that emerged from the Parnell prosecution placed criminal responsibility directly on the people at the top of the decision-making chain, not just the conditions on the factory floor. The outbreak also exposed a structural vulnerability in ingredient-based food supply chains that regulators had largely underestimated. When a contaminated ingredient travels invisibly inside finished products from hundreds of different brands, tracing it back to a single source can take weeks. Weeks during which contaminated goods are still on shelves, still being purchased, still being consumed. The scale of that recall, nearly 4,000 products pulled over the course of months, reflected how deeply a single compromised supplier had embedded itself across the American food system. May 2011, Northern Germany. Hospitals in Hamburg began reporting a surge in patients with bloody diarrhea. Within days, cases of hemolytic uremic syndrome were arriving faster than physicians could process them. Hemolytic uremic syndrome is a condition in which red blood cells are destroyed and the kidneys shut down. German doctors described the volume as unlike anything they had encountered in their careers. The outbreak was already moving through the population before anyone knew what was driving it. The bacterium responsible was Escherichia coli of the serotype O14H4. a strain that carried two sets of dangerous traits simultaneously. It produced Shiga toxins, which damage the blood vessels lining the gut and trigger the cascade of organ failure that defines hemolytic uremic syndrome. It also carried genetic characteristics from enteroaggregative E. coli, which allowed it to grip the intestinal wall tightly and persist in the body far longer than typical strains. The combination produced a rate of hemolytic uremic syndrome among those infected that had never been recorded in any previous E. coli outbreak. The Robert Koch Institute, Germany's national disease control body, was formally notified on May 19, 2011. Investigators moved quickly, but the outbreak had already peaked before they were even in the room. On May 26th, German health officials announced that Spanish cucumbers had been identified as the probable source. The announcement was wrong. Laboratory testing on the cucumbers found no trace of the outbreak strain. Spain's agriculture sector was furious, and with reason. Spanish exporters lost an estimated $200 million per week as buyers across Europe pulled back from Spanish produce entirely. The real answer came through a different method. Investigators conducted a recipe-based study at a restaurant in Lübeck, reconstructing exactly what each diner had eaten by cross-referencing billing records, meal orders, and kitchen ingredient lists. The results were unambiguous. Every single guest who developed hemolytic uremic syndrome had eaten sprouts. Not one guest who avoided sprouts became ill. The relative risk for sprout eaters was more than 14 times higher than for those who had not eaten them. The sprouts were traced to a single farm in Lower Saxony. That farm's seeds were then connected to a batch of fenugreek seeds imported from Egypt in December 2009. The same seed lot had been distributed across Europe, which explained why a separate cluster of cases had appeared in Bordeaux, France, among patients who had never set foot in Germany. They had eaten sprouts grown from the same Egyptian seeds. In total, 3,1050 people were confirmed infected across 16 countries. 800 developed hemolytic uremic syndrome. 53 people were gone, 51 of them in Germany. The median age of those who died from hemolytic uremic syndrome was 74. The elderly, as in so many of these cases, bore the worst of it. The European Union paid out €220 million in agricultural compensation to farmers whose unsold crops had rotted in the fields, while investigators chased the wrong source. Russia suspended fresh vegetable imports from the entire European Union for weeks. The cost of the false cucumber announcement, in both economic damage and in lives prolonged without a true answer, was enormous. Despite exhaustive testing of the fenugreek seeds, no direct microbiological evidence of the outbreak strain was ever recovered from them. The contamination was confirmed through epidemiology, not from a laboratory culture of the seeds themselves. How the seeds became contaminated in the first place was never determined. The precise origin of the outbreak strain and the point at which it entered the supply chain remained unresolved after the investigation closed. It was the deadliest bacterial foodborne outbreak in modern European history, carried continent-wide by seeds no consumer ever saw, inside sprouts most diners would not have thought to name if asked what they had eaten. The question of how contamination found its way into a seed shipment from Egypt passed through a Dutch distributor, reached a German farm, and ended up on plates across 16 countries was never answered. The supply chain had moved faster than any investigation could follow it.